2015, question number 2 is just one single problem. We're writing a whole entire class, which includes a constructor and a method, and also it includes its instance variables. So let's see. Consider a guessing game in which a player tries to guess a hidden word. The hidden word contains only capital letters and has length known to the player. That's important. The length is known to the player. So the guesses are always going to be the same length as the actual word. So you don't have to worry about checking for that. A guess contains only capital letters and has the same length as a hidden word. Okay, there we go. There it is. That's what we just said. After a guess is made, the player is given a hint that is based on the comparison between the hidden word and the guess. So it compares the two and it gives it a certain type of hint. There are only 3 types of hints. Each position in the hint contains a character that corresponds to the letter in the same position in the guess. What does that mean? Each position in the hint contains a character that corresponds to a letter. So, we'll see what the examples down here. If a letter in the guess is also in the same position in the hidden word, what is returned, the corresponding hint, what is returned is the actual letter. So if the letter is the same letter and in the same position in both the guess and the answer, then you return the matching letter, or you put in the matching letter. If the letter in the guess is in the hidden word, but it's in a different position, you return this. And if the letter in the guess is not in the hidden word, you return this. And I'm saying return, but in fact, later on, you'll see you have to build the string. So let's see. The hidden word class will be used to represent the hidden word in the game. The hidden word is passed to the constructor. The class contains a method, getHint, that takes a guess and produces a hint. And this is the important part. So if we built this in a driver and put in the actual answer, harps, then and then guessed then A works, but H is not guessed. Like this A is wrong because it's not matching that. So you get a plus. Because A is still in this, but not in this first position. That's why it puts a plus here. Then it says this A is correct. It matches. Because this A matches that A. So it puts that A in there. And then all the rest, yes, A is included in this, but in a different spot. And you put hello. And H works. It's in the correct spot as well, so it returns H. All the rest of these letters aren't in the word, so it puts in the stars. H-E-A-R, so E, so we already know H works. E, we already know is going to give us the star. A is in this, but in a different spot, so it should say plus. Yep. R, oh, come on. R is part of this. Is it in the correct spot? It is not, so it gives a plus. And then, wait, R is in this, right? So it's 1, 2, yes, it gives a plus. And then T is not in this, so it returns the star. And so forth. So we get all of this. Write the complete hidden word class, including any necessary instance variables, its constructor and method getHint, described above. You may assume that the length of the guess is the same length of the hidden word. We're already told that. So let's write this. Public class hidden word. So we have hidden word. It's our class. The first thing are instance variables. So we have a private instance variable. And the way we do this is just by having the answer. So I'm going to say private and then string, because the answer is actually a string. Right? Because what is this? It says hidden word class will be used to represent the hidden word in the game. So of course it's going to be the answer. And I'm going to make an empty string. So private string answer. And then the constructor. So this is the easy part. The instance variable, I think you get a point for that, and then a point for the constructor, maybe 2 points or something. So we have public. Constructors are always the same name as the class. Hidden, we don't have anything to return. We don't say void for constructors. Hidden word. And then hidden word, the constructor takes in some string. So I'll say string. And I'm going to call it word. And the constructor initializes the instance variables. So I'm just going to say answer gets word. And that's it for the constructor. Easy. That's truly the easy part. The rest of it is a little bit more complicated. So let's get to it. The only other thing it asks for is write a complete hidden word class, including any necessary instance variables, its constructor, and the method getHint. So we did the instance variables, the constructor. Now we need to write getHint. And getHint returns a string returned. So we can say public string, because we're going to return a string, and then get hint. And remember, when we use get hint, we're putting in a string. So I'm going to say string, and we're putting in the guess. The guess is what goes inside this method. So we have that guess. Now we're able to use it. And I'm going to return a string, so I might as well make a string called hint. String hint. And again, I'm going to put nothing in it. So there we go. It's a semicolon. String hint, nothing in it. Then what I want to do, the first case is, well, I mean, I was trying to say like, oh, if they're equal to each other, then you're good. But really, since we're trying to build the string when we like output it, it's kind of like weird. These aren't arrays. If they were character arrays, we could just put in a character at each correct spot if we need to. But it's a string, so we're going to be building it like from left to right. So what I'm going to do is I'm going to use this. I'm going to use this a lot. So like, so this is like a comment. Use, I guess, string. That would be the name of the string. String.substring. And then I'm going to go from I to I plus 1. And what this does is returns single character, but it returns it as a string, so I can concatenate strings like this at the I position. And I'm going to use that a bunch. It becomes really, really useful because remember, substring goes from this, and it does not include that. So this is a single letter from the string, and it makes it a string out of it. So what I'm going to do first is I'm going to say I'm going to do a for loop, and I'm going to run through my entire guess or my entire answer. Both of these have the same length. We were told that in the beginning. So I'm going to say for int I gets 0, I less than, you can say answer or guess, answer dot length and I think you put the parentheses after, but you don't get points off if you mess that up. I can't remember. And then, so for int I, so I'm running through the entire, like each individual letter in this word, in this guess or this answer. And then the first thing I want to do is since I'm running through each letter, I'm going to check each letter. So the first thing is if they're equal, then I'm going to build my hint. So I'll say if, and then I guess it doesn't matter which order I do this in, but I'm going to say if guess dot substring, and then I plus 1 dot equals. Remember, for comparing strings, you always use dot equals. Let me move this. You always use dot equals. So dot equals, and then I want to compare the single letter for the answer. answer dot substring, same thing, single letter, I to I plus 1. Close that, close that, close that. I think that closed enough. So if the strings have an equal, so I'm starting out at the very beginning. And so like on my first position, so let me draw this. 1, 2, 3, 4, 5. I think it has 5 letters for the first part, for like the example, 5 letters. So right now I'm looking at this. If they have the same character, the same, I guess, letter there, then what I can say is hint gets hint, because hint has nothing in it right now, plus the substring from either the guess or the answer. It doesn't matter because they're exactly the same. This wouldn't run, this would not execute if the letters weren't the same. So I can have guess here or I can have answer there. So if it's the same, then it'll place that letter in, right? So it'll be like that case, if they're the same. If they're not the same, then this doesn't execute. So like suppose it is the same, then it puts an H there, and then it won't do any of my else ifs that I'm going to write, and it'll increment, and then I'll move on to the next and check to see if that's the same. If it is, it'll put in the correct letter. If it's not, though, so let's go back. If this is not true, then it's going to return false, and then this is never going to execute. So we are still else if. So if this doesn't execute, we have not incremented I, so we're still looking at the same position in our word. So what's the next thing that I want to check? I mean, really, I have 3 things to check for, and it's these 3 cases. We got the matching letter. Now let's do the plus. And I'm going to use the contains method. So, so if the answer contains, so right now, like I'm still at the first one. Now what I want to do, so if the answer contains a single letter from my guess, and remember I'm running through all the single letters, so I can say if answer dot contains, and then choose a single letter, so guess dot substring, and I'm doing this single letter. Close that. So else if the answer contains one of the single letters from my guess, and it's going to run through every single one because that's what this loop does. If it contains any of those letters, and it contains it at the whatever spot, then what I'm going to do is I'm going to say hint gets hint plus, and then the plus. Now this one's a little bit harder to understand, but I'm going to try and talk through it again. So if the answer, say the answer was harps, and we guess triple A first, or quintuple A. Is that how you say it? So let's think about this. If it harps. So the first time we're looking at this for I. Are they the same? If they're the same, hopefully that makes sense, then do this. But this does not happen. I'm going to point. This does not happen because this is not true. So then we go to this. Now we're still at the 0th spot. And then we're going to say, if the answer contains this letter, if the answer contains this letter, because we're still looking at the first spot, then build your hint with a plus. So remember, we're still at this spot. We're looking at this. If this answer contains this, then put a plus here. Because we already know that this is not an H. If it was an H, it would have put it there. And then suppose everything's perfect and it moves on. Then we're looking at this one. So now I'm looking for, okay, if they're the same, if they're exactly the same. So if we look at this, Well, they're exactly the same in this case. So this would execute, this part would execute, and this would not, and none of the other else's that I'm going to make will execute. So then it increments again. So now I'm looking at, so the first time it went through, I got a plus because the A worked, and then this one got an A because they were exactly the same. Now I'm looking at this one, and the same thing happens. This will execute again. Hopefully going through that helps. But if neither of these execute, if this doesn't execute and this doesn't execute, then I know that whatever I'm looking at is just not in the words. Like the letter or the letters here are not in this. So I can say else for whatever spot, hint gets hint plus star. Whoops. And then I need to shrink this. And then I can close this, and I still need to return the string. So I close the for loop and then return hint, because that'll build it all the way through, and then I'm done. There it is. Hopefully that makes sense. The crucial part, I feel like, is this middle part. Else if answer contains. You want to, if you say guess contains, then it'll be doing it backwards and it'll do it incorrectly. So the answer, if the answer contains this letter, really the focus is that we're running through each one of the guess strings, or sorry, the guess letters. So if the answer contains this, but it hasn't executed this part, then we know it contains it, but in the wrong spot. Then we put a plus. Hopefully that makes sense, and that's it. 17-minute video again. Okay, sorry, bye.